Hi, I'm McKenna.
And I'm Ihrig, and this is our research on the pharmacological characterization of the oxytocin receptor antagonist L368-899 for Coyote receptors.
Oxytocin is a neurohormone influencing numerous social behaviors like pair bonding, social recognition, and maternal behaviors. Coyotes display pair bonding in the form of social monogamy. Oxytocin and vasopressin are two neurohormones with structural similarities. This similarity results in binding promiscuity in the brain's receptors. In order to study the influence of oxytocin on these behaviors, we must first identify that the novel drug L368-899, an oxytocin receptor antagonist, efficiently and selectively binds to the receptors in the canid brain. Image 3 displays the chemical structure of this antagonist.
To achieve our goal, we acquired 6 frozen coyote brains, sliced them using a cryostat at 20 micron thickness, and mounted them onto slides. We performed competitive binding autoradiography using increasing concentrations of L368-899 in competition with a commercially available oxytocin radioligand and a commercially available vasopressin radioligand. Figure 2 displays a sample of our audio radiographs with an antagonist concentration increasing from left to right. The top row was exposed to the oxytocin radioligand, and the bottom row was exposed to the vasopressin radioligand.
Ki values were calculated using the competition curve in Figure 1. Based on these oxytocin and vasopressin Ki values, 12.38 nanomolar and 870.7 nanomolar, L368-899 showed a 70-time greater affinity for oxytocin receptors. Analyzing Figure 1, we see the slides exposed to oxytocin radioligand, the purple curve, did display the expected decline in binding as we increased the concentration of the antagonist. The half-max binding for oxytocin receptors was identified at an L368-899 concentration of approximately 10 to the negative 7.5. This same antagonist concentration was unable to compete off the radioligand binding for vasopressin receptors. The slides exposed to vasopressin radioligand, the pink curve, did exhibit some binding density reduction. However, these slides did not develop as expected, and many were too faint for quantification.
We believe the variability in vasopressin selectivity was due to an error in our experimental design. In conclusion, increasing concentrations of the antagonist increasingly inhibits the binding of oxytocin and vasopressin radioligands. We found L368-899 is more selective for oxytocin receptors than vasopressin 1A receptors. Lower concentrations were able to outcompete oxytocin receptors while leaving vasopressin 1A receptor binding undisturbed. Replication of our experiment is needed to have full confidence in L368-899 selectivity for future in vivo experimentation.
We appreciate you listening to our presentation. Go Aggies!